For ease of the understanding of this topic, some notations are introduced so that we will not be writing everything longhand. It will be easy for us to write it shorthand, and these notations are introduced. Now look at something like this. When we have it in quadratics, we have alpha plus beta. You can write it out, alpha beta. That's the product. But when we are working, when the power is higher, let's talk about quadratics. In quadratics, when the power is 4, we are going to have something like this. Plus gamma plus delta. We are going to have something like this. We are going to have something like this. You see, so when you are writing all this out, it makes the job cumbersome. So some notations are introduced, and this makes the job easy. Now let's go straight to the notations. When you get to higher power of polynomials, you will really enjoy and understand the essence of this notation. But for now, let's line them. When we have S1, we write S1. This is about power. S is about sum of roots, powers of roots. Like this one, S1 will be alpha 1 plus beta 1 plus, depending on the power, S2 will be equal to alpha squared plus beta squared plus, depending. When we have it as Sn, it means alpha raised to power n plus beta raised to power n plus gamma raised to power n, depending if I add in beta. And we can also have it like this, S minus 1, that is alpha raised to power minus 1 plus beta raised to power minus 1. That is for S. This is about the sum of the roots, powers, in powers. After this, we also have another notation. Like I was explaining before, you can have sum and whatever. But instead of writing it out like X or Y, we take gamma, alpha. We take alpha. It will represent like every root. Like this now. If I say summation alpha, what this means is alpha plus beta plus gamma plus delta plus. That is what this means. So when you see this, this is what I'm inferring at this stage. If I write alpha beta, it depends on the power. If it is for quadratic, this is what I just need. If it is for cubic, this is what I need. Alpha beta plus alpha gamma beta. So you see, this is shorthand for all this. Now, assuming it is of higher power, like 4, like 3. Now, let's say it is for, this will be for cubic. This is for quadratic. Now, let's say I have something like this. Alpha, beta, gamma. For cubic, this is what it means. Because that is the only combination of this I can have the product of. This is okay. Now, if it is for quadratic, I'm going to have alpha, beta, gamma. Alpha, beta, delta. Beta, gamma, delta. I think it's 4. So you can see. So if I just write this alone, and you know what it means, it will make the job easier. So as we go on, there might be some other things to introduce, but knowing this, it will make our job easy. There won't be unnecessary repetition, either in writing or in utterance. Now let's go on to techniques that make the job very easy. Now let's talk about these techniques. I have summation, recurrence, and substitution. The summation and recurrence, we have made mention of them. But I want to go a bit broader now, so that you will see how it is applied even in higher levels. By the time you get to the bigger or higher powers of polynomials, you will see it will make the job fun. Now let's look at summation. This is the technique, basic techniques. This is the basic technique of getting some values of the sum, of the product, and some other things. Mainly it's about the sum. Let's look at something like this. When we have roots, alpha beta in quadratic. And we are asked to find alpha squared plus beta squared. You know, when we want to form quadratic, the main thing we need is the sum and the product. So in this instance, we are still basing on the quadratics, which we have two roots alone before we go on to the higher one. We can have the root of expression or quadratic equation as alpha and beta. And we might be asked to form another quadratic equation, or just to find the sum of alpha squared and beta squared. We might be asked to form another equation that is quadratic, or just to find the sum. It might be this. It might be, they might even ask us something like alpha minus beta. You might be surprised. And so many of these things. The only thing we need is this. We will just use binomial expansion. And from there, we carve out the sum of this. After already knowing the values of alpha and beta. And now, to start with, this is how we do it. I just work on this one. Later on, I need to work on another one. Okay, let's this is another one. So everyone has this 1 over alpha, 1 over beta. 1 over alpha squared, 1 over beta squared. All you need to do, very simple. You just look for expression that contains this. And from there, you will carve out the product and the sum. And you manipulate the product and the sum to get these values. Now, we know if we have expression this, ax squared plus bx plus c equals 0. We know already that the sum, that is alpha plus beta, is equal to minus b over a. That one is done. The product, that is alpha beta, is equal to c over a. And from this, we look for expression that we can bring this one out from. Now you can easily put this to use. And from there, we get these answers. Now let's quickly work on the first one. We have alpha squared plus beta squared. You can easily get this from alpha plus beta squared is equal to alpha squared plus beta squared plus 2 alpha beta. Which means that alpha squared plus beta squared is equal to alpha plus beta all squared minus 2 alpha beta. You know, this is minus b over a all squared minus 2 into c over a. Straight. You have gotten the answer. This is what we mean in this topic, roots of polynomials. Which means, if I can find this sum, and then, if I want to find the product, alpha squared, beta squared, will be alpha, beta, all squared, which is c over a squared. So with this too, I can find this, or I can find this too, and form a new quadratic equation. Because we know that quadratic equation is going to be x squared plus b over a x, x squared plus b over a plus c over a. And that's going to be x squared minus the sum, which is this one, minus sum x plus product. So just put this into, just keep this in mind every time. Every time. When you've gotten this two, you have gotten your answer. You have gotten your answer straight. So just substitute what you need to do at every point in time. Now, since I've gotten this, let's see how it will be if I want to work on cube. Now, if it is for cube now, all I just need to do is alpha cube, alpha plus beta cube is equal to alpha cube plus 3 alpha squared beta plus 3 alpha beta squared plus beta. And from this, I can find alpha cube plus beta cube. So alpha cube plus beta cube is equal to alpha plus beta all cube minus 3 alpha, you can see it is common, beta alpha beta cube is equal to alpha cube beta cube. So that's the product. So I can form another equation with this easily. The same thing, the same pattern you will do for this. But when it gets to very high power, it might be a bit difficult. But when you know about recurrence and substitution, you can easily work it out. Now let's quickly go to recurrence. How it is done. So we now use an example with truth that we know to work it out and explain it further. Now for recurrence, in this place we'll just do some little jogging, let me put it that way. And from there we'll gather some results. Now let's say we have something like ax squared plus bx plus c equals 0. And we have the root as alpha beta. Please note, it is good you know this basic value which you have derived from summation. That is alpha plus beta is equal to minus b over a. Alpha beta is equal to c over a. Now let's look at 1 over alpha plus 1 over beta. You know that will be beta plus alpha over alpha beta. And that's going to be minus b over a over c over a. It is going to be minus b over c. So which means it will be the coefficients of x. Coefficients of x over divided by the constants. So please don't forget the minus sign. When it gets to higher powers, we know what we do. So know these three results, and from this one you can do so many other things. Now coming back to recurrence. Why do we call it recurrence? Because we are putting the roots into the equation over and over. That's why we call it recurrence. Now, if I should put alpha into this equation now, I'm going to have a alpha squared plus b alpha plus c equals 0. You know, since it's the root of the equation, it must give me 0. A into beta squared plus b into beta squared into beta plus c equals 0. At the end of the day, I'm going to have a into alpha squared plus beta squared plus b into alpha plus beta plus 2c equals 0. Now, I want you to observe some things. This one, this constant, at the end of the day, is multiplied by the number of roots or the power of the equation. This constant, if there is constant, when you are doing the recurrence, that is what you have. You know, we are going to add it over and over again. But these other ones, they do not change because the values are changing. The values that you are multiplying them with are changing. So this is what will give us the final result you are looking for. Now, assuming I want to find the sum of the squares of the roots, it can be easily gotten here. Either cube, either raised to power 8, I can easily use this one to do it. It does need some, research and manipulation. For instance, this one now, all I need to do, just from this equation, I can easily say a s2, remember this notation, plus b s1 plus 2c is equal to 0. Please take note of this. Plus 2c equals 0. So from here, I can easily find s2. And s2 will be equal to minus b over a s1 minus 2c. You see? So, if I am asked to make another equation with the squares of the roots, I can easily get the sum of the squares of the roots from this place. And my work will be fine. And if I really want to find the cube or raised to power 4, I can do some other things in easy ways and I will get my results. When we get to examples, you will see. But please take note of the procedure. Take note of the procedure. So, instead of writing it out like this over and over, just come straight and write it like this. When you have the equation like this, you can do it like this. Now, I just don't want to jump the gun, but assuming I have a x cubed plus b x squared plus cx plus d equals 0. If I want to apply this, all I just need to do is a s3 plus b s2 plus c s1 plus 3d equals 0. And from there, I will apply whatever I want to apply. So sometimes you might need to apply this in conjunction with this to get your results. So it's good you know all these techniques. Very good. Now let's go to substitution. Now, under substitution, this is also very easy. As I have been saying, let's say we have quadratic equation ax squared plus bx plus c equals 0. And the roots, alpha and beta. Now we are talking about substitution. Now assuming we have to find another quadratic equation with roots 2 alpha and 2 beta. You know, the main way we write our quadratic equation is this. At the end of the day, it's going to be x squared plus b over ax plus c equals 0. And how do we form it? X minus alpha into x minus beta equals 0. So that's what gives this. Now, what we will need to form this one now is going to be x minus 2 alpha. Okay, so let me use x. Let's say z minus 2 alpha into z minus 2 beta. You see? But you know, we can have it in this way. Let's say I divide through this one by 2, this one by 2. I'm going to have z over 2 minus alpha into z over 2 minus beta. By the time I expand this, and by the time I expand this, you will see it's going to give me the same result. Let's do it for the first one. Let me expand this. I'm going to have z over 2 squared minus alpha plus beta into z over 2 plus alpha beta equals 0. So, on doing the full expansion, that is multiplying through by 2 squared, I'm going to have this squared minus 4 over 2 into alpha plus beta into z plus 4 alpha. So you can see at the end of the day, this one and this one equals the same thing. Because this one becomes 2. And if I factorize this one, it's the same thing. So what we are saying now is this. What will, instead of doing all this, we'll just take a value for z to represent y in this equation. We'll just take a value for z to represent y in this equation. It might be fraction of x, it might be multiple of x. Now let's look at this. In this equation now, we have x minus alpha beta. In this equation, we have x minus alpha, x minus beta equals 0. Now, if I want to, since I'm going to have, and I have it like this, you know, at the end of the day, I'm going to have x squared plus minus alpha plus beta plus alpha beta equals 0. That is for this. If I'm using this, alpha and beta. When I'm using 2 alpha and 2 beta as it is here, I'm going to have x squared minus 2 into alpha plus beta x plus 4 alpha beta. Now, what do we do? Since we are going to have 2 alpha, we are going to say that z is equal to 2x. Because in this instance, we are going to have 2 of either of the roots in this equation. What do? We will now say, okay, if z equals to 2x, that is the new root, is double of the previous root. It means that this x will be equal to z over 2. The x will be equal to z over 2. So what do? We will now put this z over 2 into this equation as substitution for x. Z over 2 into this equation. Now, it's going to be like this. Z over 2 minus alpha plus beta to z over 2 plus alpha beta. So what do we have? We are going to have z squared, so this is 4, minus 4 over 2 into alpha plus beta z plus alpha beta. So you can see, we got the same result we got in the previous So this will give us this plus minus 2 alpha plus beta plus 4 alpha beta. So we have, discussed the 3 techniques in relation to quadratic equation, so that when we get to higher level, we find it very easy. Now let's see how we can put this into use using an example with numerals. Now let's work on a quadratic equation with roots 2 and 3. With roots 2 and 3. We know that the quadratic equation is going to be something like this: x minus 2 into x minus 3. And it will give us x squared minus 5x plus 6 equals 0. That's what it will give us. Now, let's look at finding the sum of squares of the roots. Like this. We want to find alpha squared plus beta squared. It's very easy now. Just from what you have done before, you can see that this one is going to be s2, that is sum of alpha and beta squared, plus 5 minus, s2 minus 5s1 plus 6 equals 0. So what you have done before, you can easily, this one will be plus 12, that is 2 times 6. So, if you are going to find this, let's work with the, let's do summation. Let's do summation. Now, using summation. We have discovered that alpha squared plus beta squared will be equal to alpha plus beta all squared minus 2 alpha beta. And we know that alpha plus beta is equal to minus 5. That is 5. Alpha beta is equal to 6. Now, so alpha squared plus beta squared will be equal to alpha plus beta squared, that is 5 squared, minus 2 into alpha beta, which is 25 minus 12. And that is 30. And we know what our roots were. 2 squared plus 3 squared, that is 4 plus 9, that's 13. So our answer is correct. Now, let us now use recurrence. Let's use recurrence now. Now, for recurrence, we know we are going to have s2 minus 5s1 plus 2 times 6 equals 0. And that means s2 minus 5. What is s1 minus 5? Sorry. So we are going to have s2 minus 5. What is s1? That is minus 5 over 1. That is 5. So s2 will be equal to 13. The answer is still consistent. You can see. So, in this instance, substitution will not come to play because substitution is to find another equation straight. Now, we have been able to establish that alpha plus beta through summation and recurrence to be equal to 13. Now, let us now use all the techniques to form an equation with the roots alpha squared and beta squared. Let's see how it goes. From summation, we have been able to establish alpha squared plus beta squared is equal to 13. And alpha squared, beta squared is equal to alpha beta all squared, which is 6 squared. And that's it. So, the new equation with root square root of alpha and beta is going to be x squared minus 13x plus 36 equals 0. With recurrence, we have been able to get this. So this is the same thing we'll do with recurrence. It's also going to be in this pattern. Now, let us now use substitution. Because these are the things we have gotten the figures. But in substitution, you don't need to find any figure. You just work it out straight. You don't need to start finding what is sum, what is product. No, that is where substitution is advantageous. So in substitution, what we do is this. I am finding y or z to be equal to x squared. So x is equal to square root of y. So I now put this value straight into this equation, and you see how it will how it will come out. So I'm going to say root y all squared minus 5 root y plus 6 equals 0. So I'm going to have y plus 6 minus 5 plus y equals 0. And to cancel this square root sign, I have to square. In order to, make out the equation that will not contain any square root sign, I will bring this one to the other side. So I'm going to have y plus 6 is equal to 5 root y. Remember sums. So something like this has been treated under sums. So we are going to have, now square both sides. So I'm going to have y squared plus 12y plus 36 is equal to 25y. And then I bring this one here. I'm going to have y squared minus 25y plus 12y plus 36 equals 0. So I'm going to have at the end of the y squared minus 13y plus 36 equals 0. So you can see, it is fun. When you see the question, just know which one to apply. You can apply all of them. Just bring this one from here, bring another one from another point, and then you get your answer. Now let's assume I want to work on roots, which is reciprocal of the initial roots. When you are working this, nobody will give you the roots, and nobody will ask you for the roots. But we are doing this so that you will know that you got the answer. So that you will know that the answers are right. And that's why you form using 2 and 3. Now let's assume I want to say, okay, alpha and beta are the roots. Now, let us now form another quadratic equation with roots 1 over alpha and 1 over beta. We have seen this minus coefficient of x over constants. Using summation, 1 over alpha plus 1 over beta is equal to alpha plus beta over alpha beta. That's what you are getting. This is equal to minus b over a over c over a, which is minus b over c. So this is going to be equal to minus 5 over 6, which is 5 over 6. So that's the sum. The product is equal to 1 over alpha beta. That is 1 over 6. Therefore, the new equation is going to be x squared minus 5 over 6x plus 1 over 6 equals 0. So, okay, let me clear this. So, multiplying 2 by 6, I'm going to have 6x squared minus 5x plus 1 equals 0. That is the new equation. We have gone through it using summation. Now, assuming we use recurrence to find the sum, let's see how it will look like. Now, let's divide 2 by x so that we will have one of this with reciprocal of x. So we are going to have x minus 5 plus 6 over x equals 0. When we divide 2 by x. Now, if we do the recurrence, you know what we are going to have? We are going to have s1, that is the sum, minus 2 times 5 plus 6s minus 1. Yeah, s minus 1 is equal to 1 over alpha plus 1 over beta. When you do this thing, try it. Do it over and over, you see this what you get. And we know what s1 is, but we don't know what s minus 1 is. And that's what we are going to find now. S1 is minus 5 over 1, and that is 5 minus 2 into 5 plus 6s minus 1 equals 0. So this one here is going to give us minus 5 plus 6s minus 1 equals 0. So 6s minus 1 is equal to 5. So s minus 1 is equal to 5 over 6. So this is the sum of the roots. Sum of we have gotten this. And we know the product. You can easily find the product. It is going to be 1 over 6 as we have gotten before. So at the end of the day, we are coming back to this equation. Like we have done. This is the most important thing to find. Now let's also now see. If we now use substitution, what is it going to be like? Now let's use substitution. We see that y is equal to 1 over x. So x equals to 1 over y. So what we need to do now is to substitute 1 over y for x in the equation. So what are we going to do? We are going to have 1 over y squared minus 5 1 over y plus 6 plus 0. From here, let me multiply 2 by y squared. So I'm going to have 1 minus 5y plus 6y squared equals to 0. So I'm going to have 6y squared minus 5y plus 1 equals 0. So the new equation can be written as 6x squared minus 5y plus 1 equals 0. So you can see the consistency. Oh, this one is y, so x, sorry. So you can see the consistency now. So this is just to introduce you. You can use it for Q, any of them. But with practice, you will know which one is easier to use. Either summation, either recurrence, either substitution. But as you are going higher and higher, summation might not be easy to be used. Recurrence and substitution might be better option. But it's good, at least you know all of them. But summation is also applicable. There are some basic answers or answers you need to know at the tip of your finger. Like the sum of the roots, like the sum of the reciprocal, like the sum of the squares. So as you go on, you will get it. Let's see. Now, let's see if we are going to find a new equation or value of alpha raised to power 4 and beta raised to power 4. Let's find the values and let's see if we can use it to form another equation. You know what alpha and beta are. Now, let's see. X squared minus 5x plus 6 equals to 0. Now for me, I will first of all form the equation with alpha squared and beta squared. I can use substitution. And from that substitution, I got 6x. Okay. I think I got, let's do substitution. I'm going to have y equals to x squared. So x is equal to square root of y. And from there, I will have minus 5 with y plus 6 equals 0. Now, this is y squared plus 6 minus 5 is equal to 5 with y. So squaring both sides, I got, this is y. Squaring both sides, I got y squared plus 12y plus 36 is equal to 25y. So y squared minus 13y plus 36 equals 0. So this equation with alpha squared and beta squared as roots. From here now, I can easily get the value of the squares of alpha squared and beta squared. Mind you, the root of this equation is that of the alpha squared and beta squared. That is the root of this equation. So I have gotten this by using substitution. Now let me now use recurrence or summation to find the sum of alpha squared and beta squared. You understand what I mean? That is, I can use this one using summation. From this equation, I can use summation. That is sum squared minus 2 of products. Remember, so that is going to give me minus 13. That's 13. Minus 13 is 13 squared. Minus 2. What is the product? 36. And this is equal to, so this is going to be equal to 169 minus So the new quadratic equation is going to be x squared minus 97x plus 1296 is equal to 0. Now, since we have gotten this equation for square and square, why don't we apply substitution and see if we can get the same thing? Now, the equation with alpha square and beta square as the root is this. This is the equation. Now, for us to get the equation with alpha raised to power 4 and beta raised to power 4, let us make that one. That will now be square of these roots. So we are going to have z equals to x squared. So x equals to root of z. So we now substitute root of z for x in the equation. So we are going to have root of z all squared plus 13 root of z plus 36 equal to 0. I think this should be minus. This should be minus. So this one is minus 2. So we have this. The next thing now is let's minus 13 root z plus 36 equals 0. So we have z plus 36 is equal to 13 root z. Now let's square both sides. Let's square both sides. So we have z squared plus 1296 plus 72z is equal to 169z. So, on breaking it down, we have z squared minus 97z plus 1296 equals 0. So you can see, using summation to get the squares and the products, or the sum and the products, we got this. Using substitution, you can see, we don't even need to do unnecessary long work. So, by the time you are used to it, you can just play and juggle with any of the techniques as you see fit.